Okay. Good afternoon to everyone who is joining us for today's Reactor session. Today's session will look at how attackers exploit containerized Azure workloads. And we're delighted to be welcoming back David. And David is a MVP with Microsoft and will be delivering the next session over the next 60 minutes. And just showing quickly our code of conduct before we get into today's session. So this is really just a reminder to people to be kind, be welcoming and respectful to others, and understanding of differences. So if we're seeing different points of view coming through the comments, just to really keep that code of conduct in mind and to make sure that that we're creating a nice welcoming environment and kind environment to everyone. So as I mentioned, this session is 60 minutes long. That includes the Q&A. So there's a Q&A window where you are welcome to post any questions that you have, also comments and any feedback that you have throughout. This session is also being recorded and will be made available on the Microsoft YouTube Reactor channel by the end of the week, and I will post that link into the meetup page for you all to have towards the end of the week. So I'll hand over to David to get us started with today.
Hello, thanks very much for that lovely introduction, Emma. So I'll just go ahead and select the right screen that I want to share here. Are you able to see my screen now? Hopefully you're able to see that now. That's live. Nice. Awesome. Thanks very much for confirming that. So hello, everyone. Hello again. This is my second time I speaking for Microsoft Reactor London. So my name is David Okiyade. So I am a Microsoft Azure MVP, as Emma mentioned. So I have over a decade of experience in cybersecurity. So I've done consultancy, design and implementation, and I've mainly really focused on cloud security in recent years. So just focus on helping organizations to secure their cloud environment, whether that's Azure or other cloud environments. I also put out a bunch of vulnerable by design automation templates, which are templates that you can use to sort of practice some of the things that I'm talking about, with regard to just pen testing cloud environment, how you can practice them in a safe environment without going beyond the boundary of an environment that's not under your control. So anyway, so those are my social media handles on the screen. I'm very much active on social media. So if you want to link up with me, feel free to do so. And that's the link to my blog also. So here's the agenda of what I'm looking to cover today. First of all, we're going to start by looking at a different approach to cloud security education and why in a lot of my talks that I do, I tend to focus more on this aspect, and I'll give you the reason for that. So also, give a bit of containerization primer in case we have anyone on the call that's not too familiar with different containerization options in Azure, what options exist, what are the different use cases. Just quickly run through those together with Azure Container Options. And then we're going to look at the containerization security model. One of the things that I'm looking to pass across to you in this session is that containerization security can be very complex. Right, when we're talking about Azure containerization security, it can be complex, and you see the reason why when we get to that section over there, because there's so many security models that we are dealing with, and all those security models are connected to each other, and misconfigurations or mistake in one of those models can lead to being able to move laterally into other sectors of our environment also. Right, modern applications are very complex, they are distributed, and we need to take that into consideration when we talk about Azure containerization security. So we'll look at the Kubernetes attack matrix. So we'll talk about what are different attack matrix, the different tools, techniques, and patterns that attackers use. So we'll give a conversation about a discussion about that. And then finally, I'll just give like quick demo just to show you like some concepts from what we've discussed. So let's get into it. So first of all, why a different approach when we're talking about cloud security or Azure container security in this sense? Why we talk about the perspective of an attacker? My number one reason for that is that we already have a lot of presentation that focus on best practice and tools. So there's a lot that's out there that I feel like personally for me, I learn a lot when I focus on things from an attacker perspective. And also, again, there's a lot of content out there. You could go on YouTube and type, Azure Kubernetes Service best practices, and you probably get, tens or hundreds of videos, most likely. At least you can go on Microsoft website and you go to docs.microsoft.com and you see a lot of best practices around security baselines that you need to put in place. So there's a lot of document and tools out there already. Also, understanding attacker behavior is an important part of cybersecurity education. We've done this in our on-premises environment, right? So we have disciplines like ethical hacker, we have offensive security. The reason why we have these disciplines in security is because we recognize that understanding security threat from an attacker's perspective can help us to better defend our environments. Like what somebody said, a security defender thinks in terms of lists, an attacker thinks in terms of graphs, how are things connected to each other, right? So it's good for a defender to take the perspective of an attacker sometimes and think in terms of how connections are made into the environment, and that will help you be a better defender, right? So also, we want to learn from the failures of others. We want to learn what not to do. So when we read of cloud security breaches, this organization got compromised. A few years ago, Tesla's Kubernetes cluster hosted in a cloud environment, not Azure, but hosted in another cloud environment, got compromised and got breached, and people were doing crypto mining off of Tesla's expense. Those type of things, when they happen, what we should do is to try to understand how did they happen and how can we avoid that going forward. So we want to learn from the failures of others. Okay, so that is a quick overview of like why I'm taking this different approach. But that being said, let's just get into like some containerization primer. So when we're talking about containerization as a whole, we're talking about being able to take an application, most likely a microservice, an application that performs a single task, being able to package that application, the system files that it needs, the system settings, the tools, the runtime that the application needs to be able to execute, and being able to package that into this single image. That's what we are describing here, and then being able to ship that and distribute that at scale. It's what we're talking about here. But when it comes to creating container images, we're talking about using a Dockerfile most likely to create a container image. The Dockerfile is referencing a simple text file, which is a step-by-step instruction on how you build your container image or how you containerize your application. So I have an application, I want to containerize it. Here's an instruction that describes how to containerize this application. And once you have that Docker file, you can use the Docker build command. So you have a Docker file that has the instruction on how to build your container image. You run the Docker build command against that, and then you get your Docker image. Now you can ship these and you can distribute these across your entire environment. In terms of what a basic Docker file looks like that developers use, this is what it sort of looks like. And I'll go through this very quickly. And you see the reason why it's important to go through this and to try to understand what's going on here. Because this is where bad security decisions start from, right? So you make bad security decisions at this stage. It follows through the entire life cycle of your application. You have to go back and iterate your application to be able to get rid of those security issues. There's a lot deeper that we could get into a lot of this concept, but today we're going to stick to giving a high-level description of what we're talking about here. So here's an example Docker file that's used to build a container image. Now, on the left-hand side here, you see the text that's marked in blue. Those are what they call instructions, right? So you have these instructions, and then essentially you have like the commands that you're running in that. So the first line, it says from, and then it had a description of a text. So what this is describing is to say, that's the base image that we are starting from here. Like we're going to start from that base image because that base image already has the runtime that we need to be able to run the application that we were about to transfer into that. But that is where bad security decisions start, because this base image that we're talking about could be packed full of vulnerabilities, right? So it could be just a vulnerable image. It could be a compromised image that actually has malware hidden in it, or it could be just an unsafe image that maybe requires too many permissions to be able to run. So that's where bad security decisions start, is you start from when you're building your container images. So the next instruction, they're running a command. In this case, they're just making a directory. This is a Linux Linux container. So making a directory and then copying the files from the host, the application files in this case. So maybe the application files, which is written in Node.js, is stored in that location on the host, but we want to copy, it's stored in that location on the host, but we want to copy it into our image, into that location on the image. Again, you could be copying files that are vulnerable, or files that have exploits in them, or files that are not useful, right? And files that just increases your attack surface. That could be copied into the image, and then again, you have bad security decisions made, and that costs you later down the line, right? In this case, they're changing the working directory, and then essentially compiling the application, and then saying when this application executes, that's where it's going to execute, which is essentially the compiled application, so to speak. So that's sort of like a basic what a Dockerfile looks like. So once developers have like Docker files like this, they use it to build an image, right? So you can run the Docker build command again against that and specify the path that has your Docker file into it. And you can also specify what you want to tag your application. And then once you have that, if you run Docker images, you'll be able to see your images there. So essentially what we're talking about here is we're talking about three main aspects, talking about building container images, storing and distributing images, and then runtime options. The reason why it's important to understand this is this is the main point behind this. When you think about container security, you have to be holistic in your approach. You cannot just focus on we're just going to scan, because that's common these days, right? We're just going to scan our container images. That's what we're going to focus about, because there are threats when you're running your container images that you have to be concerned about, and that, again, as we'll see when we get to the security model discussion, there are threats that you have to be aware of and that you have to take care of in runtime also. So runtime defense is a big part of containerization security, right? But so is the build. To be able to limit the vulnerabilities and exploits that you're getting out into production to begin with. So is the storage and the distribution or the shipping of the images. That's equally important. So it's important to take care of things at all the different levels. So in terms of Azure containerization options, in terms of building container images, you could just use a Docker virtual machine, which is a virtual machine that has Docker installed on it, right? So, and you could use Azure virtual machines to be able to do that. So you could use that. You could use Azure pipeline. I'll show you an example of how an Azure pipeline is used to automate that build. So you could use an Azure pipeline to build container images instead of doing them individually. And that's what's more common in many organizations these days, is to use Azure pipelines. But there's another option where you can use something called Azure Container Registry Tasks, which is a way to automate the building of your images from within the service in Azure that you're using to store the images. This has the advantage, for example, if you want to automate your patching going forward, right? So for example, I'm referencing a runtime version that's now out of date, right? That's probably not something that you may not want to essentially build pipelines every single time to be able to take care of that. Maybe something that you want to automate right in the service where you're storing the images, and Azure Container Registry Tasks is an amazing service that you can use to achieve that. So those are the different options that we have when building container images in Azure, right? Here's an example of using Azure Pipeline to automate the build of a container image all the way from a developer workstation. So you have a developer writing the application code, pushing that into source control, in this case, Azure repos. And once that hits source control, that triggers a pipeline, which is another service in Azure DevOps that triggers a pipeline. And then part of your pipeline is you have tasks that will automate the building, taking the new code and containerizing the new code. And once it's done, it's going to push it out to Azure Container Registry for storage. So, and then you have the services that you can use to run your container applications, can pull those images from there and then run those images. So that's an example of how you can automate that process using a pipeline versus doing Docker build on a single developer system. So anyways, we'll see where the threats are coming later. So when it comes to storing and distributing container images in Azure, there's one main service that we are talking about, and that's Azure Container Registry. So that's the service that we use to store images, but it's not just about images. It can be used to store other container artifacts in Azure. So Azure Container Registry is the service for that. Let's move on a bit here, and let's go look at, okay, you know what? Let's just show this one and then pick that one. So how Azure Container Registry works. So again, you're using pipelines or Docker VM to build your images, you have Azure Azure Container Registry Service, and from wherever you're building that pipelines or a Docker VM, you build the image, you push the image into Azure Container Registry, and then you also use the tags for different versions of the image, and then at runtime you can pull that image specifying Azure Container Registry.acr.io. You specify the location, and that's going to pull the image into the image cache, and then you're going to be able to run that. The significance of this is watch out when it comes to security capabilities that you can do from Azure Container Registry, because it ties to the tier of the service that you select. Azure Container Registry, the basic tier, has some security capabilities, like you can do registry authentication with Azure AD that helps you to secure your identity and your access. You can do webhook integration, where you can use a service like Palo Alto, Prisma Cloud, for example, what used to be called Twistlock, right? So you can use that, and you can integrate that to say, whenever there's a new image that lands, I'm going to send that into something like Twistlock to scan the images, detect vulnerabilities, and then I can essentially control that from within the registry. The standard tier doesn't have any other security capabilities when it comes to this, but the premium tier has other security capabilities. So essentially in production, if you're very, very interested in security, you probably want to consider the premium tier when you're talking about Azure container security. So for example, it has capabilities like content trust, where you could sign your container images so that you ensure that they're not being tampered with in the registry when they're delivered to your runtime. So you can enhance your encryption using customer managed keys instead of using the Microsoft managed key. So there are some security capabilities that exist here. From a networking perspective, instead of having your service available to the internet, even though it's still protected with authentication, you may want to only have the service accessible privately, in which case you can use a capability called private endpoint to be able to implement that. So give you like a quick overview of what you can do from a security perspective, but that ties in with the tier that you have. In terms of the runtime options, there are two main container runtime options that we have in Azure, two main categories. We have the category without orchestration and the category with orchestration. So those are the two main categories that we have. And the categories without orchestration, you have an Azure virtual machine. So this helps you to understand where your developers could be running their containerized applications. So that is just a single virtual machine. You download and install a container runtime on it. That could be Docker, and then you pull and you run your container images. That could be container instances, which Microsoft calls the simplest way to run images, containerized applications in Azure. So container instances is just a managed Docker VM. I don't have to manage the operating system. I don't have to manage the runtime. Just give me a virtual machine that I can run single isolated containerized applications, or I can run maybe 2 or 3 containerized applications and stuff on that. You have Azure App Service, which is a service that's mainly focused on web applications, API applications, and mobile backends. So you can use App Service to run web applications, mobile backends, and APIs that are containerized. So it's got to be either one of the 3. You have Azure Function that we can use to run small pieces of code in the cloud, but we can also have our microservices as small pieces of code run as containers rather than running as direct code. And we have Azure Batch, which is a service for high performance compute that we can use to schedule a task or automate a task across multiple compute units to be able to accelerate delivery. So I've got like 10,000 MP4 files to convert to MP3. I schedule them on Azure Batch. It's going to schedule them across multiple compute nodes and finish that maybe within hours, something that would typically take maybe weeks or months to complete if I use a single virtual machine. Those are the options that we have. These options are what people are going to be using when they don't need orchestration capabilities, like automatic service discovery and other capabilities like that. So just be aware that your developers could be running containers in any of the services in Azure. But then we have the options that have containerization, which are 3 main services in Azure. We have Kubernetes service, we have Service Fabric, and we have Azure Red Hat OpenShift. So are the 3 options that we have. So Kubernetes service, it's what many people already probably know. So the same Kubernetes that you can deploy by yourself, but it's managed by Microsoft. Service Fabric is a bit of an interesting one. So when Kubernetes first came out, it has no support for Windows nodes. So it only supported Linux nodes. Microsoft were encouraging developers to adopt containerization, but they didn't have an orchestrator that supported their workloads. So Microsoft built Azure Service Fabric, which initially provides similar capabilities, but it has a bent towards the Microsoft stack. So that was where Service Fabric came from. And it's the service that actually powers a lot of other services in Azure. Services like Azure SQL run as containers on Azure Service Fabric in the backend. And we have Azure Red Hat OpenShift, which OpenShift is gaining ground a lot these days. So that's a managed service, managed OpenShift cluster that's available in Azure. So hopefully that helps you to see like what the container landscape looks like. So let's take a step further and let's go to have a look at some of the different security models that are involved when we're talking about how an attacker sees your environment and what they're looking at, right? So how an attacker sees your environment and how you should also be seeing your environment. So when we're talking about the modern application stack, as mentioned earlier, it's very distributed and it's highly complex, right? And in many cases, we're dealing with diverse security models, right? And those models in themselves are complex, but then add on top of that, other models, things get complex very quickly. So in this case, we're talking about, we have to look at the cloud security model or the platform security model in this case, right? And in our conversation today, that will be Azure, right? But that could be any other cloud security model. And there are security issues that could happen on this model that we have to be aware of, because that could also impact our containerized workloads. So you could misconfigure services that you're using on the platform. You could misconfigure the services of even the platform itself and misconfigure your access to them. You could overprivilege identities where they have too many privileges on the platform. You could have platform bugs. Those happen less, but they do happen, right? There was one recently that was reported where someone was able to break out of an Azure App Service and be able to break out into other environment. Of course, that was reported to Microsoft and that was quickly patched. But those do happen even though they are far between. So just be aware that you have those issues. Then you have your orchestrator, which it's a completely different security model from your platform. So now you have to worry about these also. And on the orchestrator level, you can have issues like orchestrator misconfigurations, weak credentials, to access the API of your orchestrator. You could have outback gaps because again, the outback of just Kubernetes alone is it's very complex, right? So there are ways to simplify those on Azure by tying the Kubernetes outback model and tying that to the platform outback model, so that essentially you have to only look after, when it comes to identity and access, you look after that in a single place. And I highly recommend doing that. That would definitely save you a lot of time rather than having to worry about the Kubernetes outback model also. Then you have your nodes, which are what's actually hosting your workloads. And you could have issues like kernel bugs or file permission errors and operating system misconfiguration, third-party library vulnerabilities, all the different OS and kernel security issues that we've all known about that also exist in when we're talking about containerized workloads, and we still have to look after those. Looking at the container runtime, a lot of Kubernetes is moving away from using Docker runtime to containerd. But regardless, you still have to look after that, right? Because that can also be an entry point into your environment if you have security issues on the container engine model. So in this case, you have issues like exposed secrets or root privileges or vulnerable images that you're pulling and you're running on your runtime, and you have insecure networking that you've configured. So those are issues that you should be aware of and should look at. Then you have your application code, and your application code also has its own security model that's completely separate from all these other ones, right? It could be SQL injection, cross-site scripting, remote code execution, memory corruption, dependency vulnerabilities, all these issues that you could get on this level. So this gives you like a quick overview of why this is complex, right? You can see the different models that you're dealing with. So here's what we've essentially established when it comes to Azure containerization security models, be holistic in your approach and look at every single aspect of your stack, right? So don't ignore one aspect of your stack, because that could be the one that you ignore may be the one that an attacker uses to get into your environment. That's how an attacker sees your environment. That's how you should be looking at your environment. So what we've talked about so far is we have our code, and our code is running in a container, and the container is running on a node. And the node is and the container is running on a node, or it's running on a platform service. And then we have orchestrator to automatically orchestrate our workloads across the different nodes. And we have the Azure Cloud Platform itself in terms of security model. So apologies here, I'll need to quickly close and reopen my PowerPoint because it's just gone completely blank on me. So things like that, I believe it happened in the past. So let's go sort that out. And let's make sure that I can see what I'm talking about. So let's get back to, here we go. I think it's good now. Okay, so we've looked at that. So, and one of the things that I want you to pay attention to here is that an attacker, for example, is able to gain shell access into an application vulnerability. What that could mean is that they could break out of that into things like your node, and they could probably break out of that to be accessing your orchestrator to access other workloads that you're hosting, and even to break out of that to be able to gain access into your cloud platform, because all these different layers are all connected to one another. And it could go the other direction. Somebody gains access to a cloud credential or to the cloud platform, can initially use that to compromise workloads and compromise sensitive data that only your workload should have access to, or maybe even able to exfiltrate your source code directly. So just be aware that all these models are connected to one another, and you have to see them that way. So let's go look at the attack matrix, right? So there's what an attacker looks at, and is the different objectives that an attacker is trying to achieve when they see your container environment in Azure. So first, they're looking to gain initial access. That could be maybe you're doing your own internal pen testing, and you've given maybe cloud credential to a pen tester. If it's mainly from a malicious attacker, that could be someone just looking from the outside and looking at your environment and looking for an entry point. And there are different ways that an attacker will be using to try to achieve this objective. So look at this as the objective of the attacker, looking to gain initial access. So that could be using a cloud credential to gain access into your environment. So look at that a bit further down. So maybe to compromise a cloud credential, even if that is just reader permission into your environment. If I'm able to compromise just a reader permission, what can I do in your environment? So other things like, for example, stealing the kube config file, which is like stealing a cache token from a compromised administrator workstation, and then being able to use that to make unauthorized calls to your Kubernetes API. So that could be you're hosting a publicly available application, and there's an application vulnerability that an attacker has detected. That could be on your orchestrator level, where you have like some of the supporting components of the orchestrator that's exposing a dashboard, and you have no idea. So you have to look at all the different components. Kubernetes, the CNCF landscape is massive, right? You have all these different supporting services that you could have. What are exposed in that area? So these are different areas that an attacker could use to achieve that objective of initial access into your environment. Again, we'll talk more about this in other slides. So, and then the attacker is looking to execute code in your environment. That's the objective here. We're going to execute a code in your environment. And in that case, so that could be after exploiting an application vulnerability, being able to gain remote code execution into the container itself, and then being able to execute code within the container, right? So it's like bash or command inside the container. Or what an attacker could also do is, depending again if they compromise that, they could spin up a new container in your cluster and spin up a new container, and that will allow them to be able to execute certain code and maybe to try to gain access to things like your API and things like that. So it could be just you've left certain tools in your container images, and a developer, an attacker able to SSH into that, and then being able to execute code within your environment. So there are different options that attackers could use to achieve that. Then we have persistence. So this is where an attacker has already gained access into your environment, but what they're looking to do is to make sure that if you can remove the entry points that it came in through, they have another way to get back into your environment. And a typical way that attackers use that is to just spin up a backdoor container. So just spin up a container somewhere within your environment that maybe has a vulnerability that allows them to do remote code execution, or maybe a backdoor container that's making outbound call to a command and control center, and then that they can use to send instructions into your environment to execute. Right? That could be a writable host mount path, which gives an attacker permission to be able to write to certain aspects of the node itself, of the host itself. Right? Or that could be just set up a Kubernetes cron job if they're able to compromise the orchestrator level, being able to set up like a Kubernetes cron job so that if you, for example, disable a particular access, they're just going to re-add those access using the cron job anyway. So be aware of those different aspects, those different points. So privilege escalation. So here an attacker has a credential, but then they're looking to get access to other credentials. So in this case, a privilege escalation, that could be a privilege container. So container that has the permission to run with high privileges. That's why you've got to be careful about container that can that are running as permission like root. Well, you need to be careful about those. So cluster admin binding. So this one has to do with the halfback model of Kubernetes. So things like access to cloud resources. So again, if they're able to compromise something like a container, be able to move over to access cloud resources and then do credential hunting to steal credentials to access other part of your environment. Defense evasion. So this is where an attacker is trying to clean up their activities. The objective here, trying to clean up their activity so that you're able to identify that. Because if, let's say, you're shipping off your logs of all these containerization options, you're shipping off all these logs into like a security solution that's doing analysis on them, and attacker will probably want to ensure that those logs doesn't get into your security solution that can alert you and identify you as to what's going on. So they can try to clear container logs. So there are certain activities that one could probably monitor for and check. Someone trying to clear container log in an environment. People trying to delete Kubernetes events in an environment, or connect from the proxy server. So there are different ways that attacker could use to achieve that objective. And again, I'm moving very quick here, but what I'm planning to do after this, because this is an introduction, there's no way we're going to be able to cover all of this in full details within the short time that we have. So, but it's sort of like just a plug also, just so you're aware. After this, so every week I will be putting out content around each of these aspects. And I'm going to be doing demos on how attackers do initial access in an Azure container environment. And I'm going to be showing you demos of how they exploit cloud credential. I'm going to go through every aspect of this one after the other. So do follow me on my YouTube channel if you're yet to, and do make sure that you subscribe to my YouTube channel also, because I've got all the content planned out, and from next week I'll start releasing this. Okay, anyways, let's move on. So credential access. So this is where an attacker is trying to access credentials into your environment, maybe trying to steal sensitive data. Discovery, an attacker is trying to discover what the landscape, what the different targets that they could focus on are. Lateral movement, an attacker has an environment access into your environment. How can I move laterally within your environment? So different methods that attackers use to do this in Azure container environment, right? So it's like container service account, being able to use that to move from one namespace and even move into another namespace in your environment, right? So application credentials in configuration files. And then once you have the application credentials, then an attacker could potentially use that to go access something like a database, for example. And now they've just moved away to accessing data directly. And then the impact is where an attacker is just looking to cause damage into your environment. So maybe they're just destroying data, encrypting data, exfiltrating data, just denial of service. So that's the different main areas. But what I'm going to do today is I'm going to just look at the initial access, and I'm going to show you like a quick demo of how an attacker could, for example, move from cloud credential to being able to access credentials, right? Or access credential using this point, and then being able to now tie in that credential to be able to essentially access other parts of your environment, and then being able to access like your cloud resources using that. So how, because this attack chains are typically not just like, just one thing or the other. It's usually like a chain of, okay, trying to use certain methods to gain initial access. And then, okay, if I have initial access, let's do some discovery again. Let's see what we can find, what's available to be able to attack. What's vulnerable over here? Okay, maybe let's begin to execute some code. Let's begin to see if we can steal other code, other credentials that will allow us to escalate our privileges. So it typically moves across a bunch of all of this. But again, I'll be doing a lot of this. Follow my YouTube channel. From next week, I'll be doing that every week. So let's look at initial access to begin with, and then I'll show you the demo, and then we'll take questions. So initial access, how an attacker gains initial access into your environment. So the first vector here is where an attacker is using cloud credentials to compromise your containerization services. And that could range from an attacker is targeting your users, maybe with phishing campaigns, to an attacker compromising the workstation of your administrator, or to an attacker gaining access to something like the reader role in an environment. That could range from anything, but an attacker is targeting your users, not necessarily your containerized services or your containerized workloads where you're hosting your workloads in themselves, but to see, can we steal cloud credentials? Or maybe they're just doing a quick scan through your public repos and see if you've left certain credentials exposed there. Right. So when it comes to this area, there are different things that you need to consider when you're looking to mitigate those kind of threats. Right. Here's a question to ask yourself. If you're gonna, because I've seen this happen a lot, and this is part of the demo that I'll be showing to you. One of the questions you ask yourself is, the users that have access to my Azure environment, now forget your containerized workload, your Azure environment, because that, again, like you see, all those models are connected. What permissions do they have today? And which of the permissions do they have they actually used in the past 8 months or in the past 1 year? Because the mitigation here is least privilege access. That's the main mitigation that you can do here in terms of the cloud credentials, least privilege access. But then how do you uncover opportunities to apply least privilege access? Ask yourself that question. What my users currently have, what's the percentage of permissions that they have they actually used? Then you uncover those options, those opportunities. Also, you have to look at the scope that you've given people permission. Somebody needs access to be able to read certain information for an Azure storage account, and you've applied that access at a management group level, and that management group has 15 subscriptions under it, and this is the resource that the user really needs to be able to access that. Why have you done that? Because now, if that credential is compromised, the attacker could then use that to move laterally to attack your containerized workloads, not only in that subscription, but also in all the other subscriptions that are under that management group. So that's what you need to watch out for to be able to mitigate against those types of threats. So in this, the other case is compromised images into registry. So for some reason, an attacker or your users or your developers have been able to get certain images that are bad, and then they're using that to run containers in your production environment or your live environment. So there are three main categories to this. So you're talking about just vulnerable images. So those are images that these are images that the different runtime or the different components in those images are out of date. The mitigation to vulnerable images is you do constant scanning, constant assessment. So once your images hit the Azure, once your images hit the Azure Container Registry, you want to be accessing them to see do they have components that are vulnerable, that are out of date. So again, another service that you can look into is a service like Prisma Cloud Compute does an amazing job of that. So it can help you do just continuous assessment of your images, the images that you are hosting in your container registry. So watch out for that. But it's not just vulnerable images. There are images that are also just unsafe. So they are not necessarily vulnerable, but they require too many privileges to be able to run, to be able to do what they're doing. So you need to watch out for those also. But they are also compromised images. These are images that actually have malware in them, right? So you need to be looking at it from all those different angles, and you need to be identifying those before they cause you further problems down the line. Again, Prisma Cloud Compute, look into it, can help you to really take care of like all these different aspects that we're talking about. So let's move on very quickly in the interest of time. Let's see. Oh, I've got to move on very, very quickly. So kube-config file is a common one. So this is where an attacker is not necessarily going after your workloads, they're going after your users, right? So a quick example of that is, if I discard this, so here's an environment, an admin workstation, and there is a Kubernetes environment over here, right? That the admin could have access to. And for example, let's go to the admin environment over here. So apologies, too many stuff on my screen. So yes, let's say a developer is working on this workstation and they need to be able to gain access into that. We go ACR get credentials, get sort of like the resource group of the credentials. So let's put that in there first of all. Resource group. Well, these are the case get credential resource group. Let's get that resource group from there. And then the name of the cluster that the admin wants to be able to gain access to is that, right? And you get a fancy message that says I've merged. So essentially this user or this admin has certain privileges on the orchestrator level in this case, right? And they're able to get the credentials based on whatever access control that you've configured, and they're able to use that to authenticate. So, but what happened in this case is what actually describes the cluster that they're accessing is actually stored in that location over there, right? So that's essentially what gives access into that. And what could happen is an attacker, if they're able to compromise this workstation, for example, could do something like they could zip this up. And let's just do kube-config.zip, zip that up, and could go to home. And let's go to home Azure admin, cube. Right, and oh, sorry. I do not have, what did I do? So yeah, let me quickly install that. Yeah, so so once that's installed, I can run that. So initially just zip the whole thing up. Right. And that's done. If I do a list, oh, sorry. I see what I'm missing here. So I'm copying that from that location there. 1 minute, let's go back. Oh, okay, I can see exactly what I've missed. So I'm getting the thing wrong. So let's go do that again. And let's go do that. And I can specify that location. 1 minute. Where's the stuff? So it's in the roots. .cube. Right, and if I do a list, I've got that, and then an attacker could, for example, just exfiltrate that and send that over into like an Azure storage service somewhere, and then they can download it on another machine, and then they can just reuse that on another machine. Right, so an attacker could go, let's say, over to containers, create exfil. Okay, I'm logging in as a user here. Let's go do that as an admin. So if I go over here, And if I go on my containers, let's go hard. You create that. And now I can just exfiltrate that credential and send it over to this environment, and I can copy that. So let me get all of this. And then essentially, you know what? I'm just going to skip this because I'm looking at the time and I want to get to the second one. So essentially, I could just take that, send it over to an Azure storage account, download it on their system, and then use that to access your environment. Again, if you want to see more of this, follow the video series that I'll be doing after this. So let's move on very quickly, and let me just quickly talk about the rest of the initial access and then bring this to a close. So, so that's kube.config file. So stealing that from a compromised admin clients to gain unauthorized access to your cluster. So containerized applications that are public facing can also allow an initial attack access. So application security is always application security. So if you have insecure code, it's insecure code. So one of the things that you can do to protect yourself against that is make sure you're doing your own assessment, your own vulnerability assessment all the way through your application lifecycle. Also, if they're in production, make sure that when you're doing a list of the different public IP addresses that you have in Azure, make sure that you include in those the load balancer public IP addresses that are feeding traffic into your Kubernetes environment. So make sure you do a constant assessment, vulnerability assessment of what you have that are accessible publicly, and make sure you catch that before an attacker does. Expose Kubernetes dashboard. So it's not only Kubernetes dashboard, but other supporting services that you could be using. So just make sure that you're finding out if you're deploying, a daemon set somewhere in your environment. Make sure you're finding out exactly what is this thing deploying into my environment and exactly what is it exposing into my environment. Don't just take like a YAML file and just run it and just go, boom, it's working, it's done. Make sure you have an idea of did they implement a service? Did they deploy like a cluster IP? Did they deploy a load balancer? Did they deploy an ingress controller that's now giving another access into my environment through a dashboard that I have no idea about? So those are different aspects of initial access. So what I'm going to do is I'm going to go show you like a demo of how an attacker in the short time that I have, how moving from the cloud model to this. So for example, you have got like a web application here that has like a managed identity. Another can exploit a remote code execution vulnerability, and being able to use that to steal the token of that managed identity. And then once they've stolen that, they ended up with a reader permission into your Azure environment. So this aspect of it, I'm not going to be showing you that, unfortunately, because of time. However, if you go to my YouTube channel and you search for how vulnerable is your Azure environment, you see a demo of how I showed how an attacker could perform that attack chain. You see it over there. So anyways, now we have a reader credential. So this is not something that's like specifically to privilege, just reader permission. An attacker using that to enumerate what you have in your Azure environment discovered that you have container registries in that environment. And what reader permission has access to be able to enumerate the container images that you have. So they begin to enumerate that you have certain container images. But one of the things that many people may not know is that the reader permission has the permission to pull images from the registry. And an attacker can begin to pull your images from the registry and begin to do credential hunting, and in this case, find certain credentials that you've exposed in that environment. So let me show that to you very, very quickly. Well, I'll move very quickly because of time. So here's like a reader permission that an attacker has managed to steal into this environment. So if I do easy group list, right? So we can list, but they don't really have permission to do much beyond just that. So what I'm going to begin to do is let's begin to see what an attacker does once they have a credential like this. So first of all, we want to see what permission does this credential have in the environment that we have access to. So let's go back and let's go sort whatever mistake that I've made in there. Let's go sort that out. So, okay, so let's go sort that out. So the first thing that I need to do is I need to find out what the credential that we got, what user does it belong to. So let's clear the screen. And if I do an echo of username now, now that's the user that this credential belongs to. So an attacker, after you have that credential, you begin to find out what permission does that have in the environment. And in this case, just enumerating, show me all the subscriptions in the environment, show me the permission that the role that has been assigned to this user, and the user has reader role. Okay, as an attacker, you know that the reader role allows us to be able to list different services that exist in this environment. And one of those services that we can list and read are container registries. So show me all the container registries that exist in this environment, and I found one. And as an attacker, you know that just reader role allows me to be able to dig deep and see what container images exist within that. So that's exactly what the attacker will be doing in this case, which is, let's see what, and they're able to find that there is a container image that's hosted, that's stored in that registry. And what an attacker can then begin to do is they can use the reader credential to log into that container registry and begin to pull images. So be aware of that. Reader permissions can pull images, and what that means is that's an opportunity to escalate privileges, because you can then on for credentials. Oh, sorry. Why is he doing this? Let's go back to that. Let's get the right command, and let's run that again. So able to access that with the reader credential, and then able to pull down this container or any other container images that exist. So essentially at this point, you just dump out all the container images that exist. If I do a Docker image list, you can see the repositories and images that exist over here, and then essentially can begin to do credential hunting. So what I'm going to begin to do here is I'm going to do a quick, just run this, see what it does. Right, so let's see. So it's running that, still on the attacker system over here. If I do that, I can see that that's running. And essentially, I'm just going to begin to just dump out what exactly exists in this container image that's been able to download all of them. And essentially, okay, let's go fix that, because we have to get the name right. And if you run that, so essentially in doing all that, the attacker has been able to uncover that there is an Azure Service Principal information that exists over here. So the next thing to do is to load that up using AZ login, and then begin to see what permission does that have. Does it have permission to a database? I've got reader permission, I can list everything, and then I can correlate that with whatever permission this has and see if I can move further in the chain. So that just shows you that, again, how all these different threat models are connected together, and you have to have a look at them. I'll highly encourage you, again, as mentioned, have a quick look at Prisma Cloud Compute. It can really help in terms of your security with with how you're building your container images, you're shipping and you're running. So being able to do continuous vulnerability and compliance assessment of your container images, but also being able to do like a runtime defense. So for example, in this case, if an attacker tries to have a shell access into one of your container images and begin to execute certain commands that are suspicious, being able to stop that, right? Or being able to alert on that, right? And that cuts across your entire Azure environment. So whether you're hosting your container images as on Azure App Services, whether you're hosting them on service, container instance, Azure Function, so regardless of what Azure service that you're using to host your container images, then you can get that protection across on all of them. So that's it from me. So I've rushed through a bit of that, but however, again, as I mentioned, I will be showing, and I look forward again to be back on the Microsoft Reactor. So I look forward to going much more deeper into some of these other attacker objectives and how they do that in your environment. So we've only just touched the tip of the surface. There's a lot of aspects that we could tie in together. So essentially, the one I've showed you today is how that's tied together. And then using cloud credentials, we're able to use that to gain credential access into the environment, and then we can begin to use that to access cloud resources to move laterally. But there are other combinations of different chains that attackers could use. So thanks very much again. I hope you found that useful. I hope you found that beneficial. So I'll take any questions now. Emma.
Hi, David.
Hello.
Thank you so much for delivering today's session. That's great. And we do still have a few minutes for questions. Haven't had a lot come through yet, but as I said, still about 4 minutes.
Yeah.
Someone has just asked if you could post the link for your YouTube channel.
Okay, I'll post it and I'll also put it up on the screen again. So again, Microsoft Azure MVP, I put out a lot of Microsoft Azure content. Microsoft Azure is an amazing platform. In my opinion, one of the best when it comes to security by default, which is not by default, which is when it comes to security in terms of priority for a cloud service provider. Microsoft prioritizes security. So, and as a security person, I love that. So that's my YouTube channel. I'll copy that and I'll paste it in the chat window also. But that's it in case you want to take a screenshot of that. Let's copy that. Let's put that. Nice. So, if anybody has any questions, feel free to. Thanks very much. Oh, somebody posted that also. Thanks a lot. Thanks very much. Really appreciate that, Emma. Thanks.
That's fine, no problem. I don't see any more questions coming through yet, but if there are any follow-ups to today's session, you can always ask questions on the meetup where you signed up to today's session, as well as reaching out to David on his contact information, which he's already shared. As I mentioned as well in the beginning, and just as a reminder, this session has been recorded. So what we do with those recordings is post them on the Microsoft Reactor YouTube channel. I can send a link into the Q&A of that channel as well. And once it's live, I will then post it into the meetup page where you signed up for today. So that channel in there in the chat. Okay, and I believe, David, do we have a Learn TV link to share today to attendees just for any follow-up learning?
Yes, absolutely. So one of the thing I like again about Microsoft is the amazing documentation. There is a workshop that you can access in Microsoft Learn TV that walks you through how to use the different containerization services in Azure. So as a security person, I recommend go through that. So I'll bring it up on my system now. Yeah, so to go through that, because if you're going to be securing your containerized workloads, you have to know the services themselves, and you have to know like what you have to look after in terms of what you're responsible for from a security perspective. So I'll put that link into here. So it goes through Azure containerization options, and it's gonna walk you through how to use each of those different options. So here we go. So there it is. I'll put it in the chat window. Let me see if I can put it there. So Emma, I'll just reply to one of your published comments, if that's okay. So I just put that in the comments. I can also go to, so I can also go to make an announcement and put that in there. Yeah, so that's a nice one. So going to be doing container security in Azure, make sure you do that workshop. You give you the basics to know about the services that you are going to be looking after. And then once you have that, then you can build on that. How does an attacker attack this service? What different security models that we've discussed? What approaches will an attacker take? And then how do I mitigate against these different threats?
That's great, David. Thank you so much. It's been such a pleasure to have you back again, delivering another session with us. And I do hope we have you back again very soon. Thank you to everyone who's attended today. As always, it's great to have you here, and this is why we're doing these sessions, is to make sure that we're facilitating our developer community. So hopefully we see you all back again soon at the next Reactor session, and I will leave you there. Thank you and enjoy the rest of your day.
Yeah.